Good morning, students. This is Mrs. Gerhardt, and what I would like to do is offer up a sample tutorial to address any concerns that there might be about dimensional analysis. Dimensional analysis is the go-to problem-solving method of inorganic chemists, in fact, all chemists. So it is critical to be able to master this process and then rely upon it throughout the AP Chemistry course. So what I'd like to do is to go through some sample problems, and I will offer up tips for problem solving as well as remind us of significant figure rules. So let's dig in. Convert 2.54 feet per second to miles per hour. Dimensional analysis is a unit conversion method, so we'll start out by looking at some simple English to metric conversions. Notice I read this as feet per second. Now, if this is given in a problem, then the feet become the unit in the numerator and the second becomes the unit in the denominator. If you feel more comfortable, we can place a 1 underneath, and if we want to respect sig figs, there's three non-zero numbers here. There's 3 sig figs, so therefore we would put 1.00 seconds if we truly want to respect the sig figs of our given. Whenever you hear a per, that of course means whatever unit follows would be in the denominator. This is our given. We need to convert feet per second to miles per hour, or we need feet to read miles in the numerator and seconds to read hours in the denominator. So, when in doubt, we're always going to start with our given. 2.54 feet per second. Let's just concentrate on converting 1 unit at a time. I need feet to go to miles. I'm not expecting that you know English to English other than what is just common everyday knowledge. I don't even expect you to know that there's 5280 feet in every 1 mile. I would provide that. I do expect you to know, however, our time relationships. Now, seconds are in the denominator, so to cancel them, I'd put them in the opposite place. Now, we could write just S for second, but I just want to make sure it's a little clearer here. Second would go in the numerator so that we can cancel them. Now, if you know how many seconds there are in an hour, 3,600, you're fine to go right from seconds to hour. But you might be more comfortable taking smaller steps, going from second to minute, and there's of course 60 seconds in 1 minute, and then 60 minutes in every 1 hour. So what will happen is, feet cancel, we'll be left with a mile, and then seconds will cancel, minutes will cancel, we'll have miles per hour left. These are exact defined relationships. These have an infinite number of sig figs. This is actually a measurement. So this limits us to 3 sig figs. Here's 3 sig figs. So we're limited to 1.73 miles per hour as our answer. And that's a reasonable answer. Of course, a very, very small number referencing what speeds we travel at in our vehicles. But if we take our given, that's definitely a reasonable answer. All right, proceeding onward. This is very similar, just converting between simple measurements, and I just wanted to reiterate again that you would not be expected to know the relationship of, for example, fluid ounces in a milliliter. I would provide that. Let me just give you this worked out so you can give it a try on your own. Oh, these are the upcoming problems. Sorry about that. But if you want to pause it and take a look at my work. Now, I chose to go from pounds to grams because of what we were given. And then right from fluid ounces to gallon. You may have gone from gallon to, say, pint or to quart, and that's fine also. But I just went this route because of what we were given in the problem. And your answer, 3 sig figs, 0.288. Now on to the third. Silly example, I know. The biggest piece of fudge ever created weighed 3,010 pounds. The recommended serving of fudge is 28 grams. How many servings did this piece of fudge yield? So this is what I want my answer to be. The number of servings. All right. We know that the piece of fudge weighed this, and that per serving is this. So it's 28 grams, 310 pounds. So how do I use these to get servings? Sometimes we have to make up our own conversion factor. The recommending serving for one person is 28 grams. So a serving is 28 grams per person or per one serving. Now, I want serving to be my ending unit. So I know when I set up my problem, I want this conversion factor to actually be flipped. I need serving to be in the numerator, and the grams then will be in the denominator. All right, let's get started. So, 3,010 pounds. All right, well, where do I go from here? Well, I know probably my first step is to cancel pound because I want to end up with serving. The only other information I know is how many grams there are per serving. So I'm going to go from pounds to grams. I would relay this information to you. There are 2.016 pounds in every 1 kilogram. Now this is a measurement, so this will limit our sig figs, the 4 of the 2.016. Pounds are gone, we're in kilograms. Well, 1 kilogram, 1,000 grams, exact relationship will not limit sig figs. Check it out. There's 28 grams for every 1 serving. Now, this would be exact. 1, you are counting it. So this number has 3 sig figs. 4, this doesn't count, and 2. So I'm limited to 2 significant figures in my answer. So there will be 49,000 servings within that piece of fudge. Okay, moving onward. Now, I chose this example as a reminder to never be overwhelmed by the number of words that are within a problem. Never, never, never. It is simply ink on a page. Do not let it intimidate you. Let's just break it down as we go. A Peters student was applying to college and wondered how many applications she needed to send. Her counselor explained that with the excellent grade she earned in chemistry, she could expect to be accepted to 2 schools out of every 3 that she applied. She immediately realized that for each application, she would have to write 3 essays, and each essay would require 2 hours of work. For each hour of serious essay writing, she would expend 500 calories. How many calories will this student expend to get 10 acceptances? Whew! Let's see everything that we're given. She could be expect to be accepted to 2 schools. So 2 schools accepted out of every 3 schools that she applied. All right. For each application, so for every 1 application, she would have to write 3 essays, and each essay would require 2 hours of work, and for every 1 hour of work, it would be 500 calories. The question is, how many calories would the student expend to get 10 acceptances? So there's another given. And this is what I want my end unit to be. So do you see, I really broke down everything within the problem that I could use as a conversion factor. Now, it doesn't mean that I'm going to be multiplying these in order to each other, so maybe I'll just box them in. And then, of course, I also have this, which we could put over 1 if we wanted. Now, I always encourage you to start with the simplest given. Start with the simplest given. That often will lead to the greatest success, often. So, conversion factor, conversion factor, conversion factor, and conversion factor. This is a combined unit, or series of derived units. This is a simpler unit, so I'm going to start with him. All right, so 10 acceptances. Well, I know that I'm going to want to cancel that, because I don't want that as my end unit. I want calories. Well, here. There are 2 acceptances for every 3 applications. Okay. Oh, and for every 1 application, she has to write 3 essays. So I've used this, I've used this, and I've used this. Well, for every 1 essay, it requires 2 hours of work. And for every 1 hour of work, it's 500 calories. Now, whenever you work this out, you get an answer of 45,000 calories. This is what your calculator will read. Well, 10 acceptances, we could say that that's exact, that's counted. That doesn't limit sig figs. 3 applications, 2, this is exact. 3 applications, exact. 2 hours of work per essay, that was probably measured. 1 sig fig. 500 calories for every 1 hour of work, probably measured. 1 sig fig. So, how do I convert this to 1? Here's where our even odd rule comes in. So we need to round this. We look next door. It's a 5 with nothing else but zeros. If any of these digits, what am I saying? The even odd rule does not apply. These are zeros. Yeah. Little bit of summer getting to me. So we would then round this up to 50,000. Please forgive me. If this would have been 45 with nothing else after it and we needed to round it to 1 sig fig. So sometimes, very, very rarely, this will happen. If there's anything following the 5, including a 0, you would round up. However, if there's nothing after it and we can only report 1 sig fig, you look to the number that you are rounding. If it is even, you keep it as is. If it were odd, then we'd round. If this were 5, 5, then we end up rounding it to 60. I apologize for my blunder there. So the answer is 50,000 calories. I have a couple more that if you feel that you need a little more practice, or if you just want to open up the next video and just pause it whenever you see my work, try it yourself, make sure you get the correct answer with the correct sig figs. As always, please feel free to email me with any questions.